In this example, we're going to look at building an ECS system model in Flowmaster V7 Aerospace. Here we can see our ECS system, and beneath this we've added a background image to help someone that hasn't built a model visualize what's going on. So what we have is a number of cabin sections, each representing 3 rows of seats with air supplied, which we'll look at in a bit more detail now. First of all, we'll zoom into the air intake. Air is supplied from 2 sources. One is recirculated air, driven back through the system by these fans. The second is fresh air is supplied by these 2 flow sources from the cooling pack. Air is then supplied through the cabin, through these overhead ducts, which pass through the whole length of the cabin to the end, through some ducts, and then either pass into the cabin through this ball valve, which represents a Gasper valve, or through constant airflow down the side of the cabin through this orifice plate, then transition. The 3 rows of passengers and the heat load those passengers will impart into the system are represented using this heater-cooler component, which has a heat load of 0.4 kilowatts applied. We then have these larger pipes, which represent the airflow and mixing through the cabin, and the air is drawn through these orifice plates into another section of ducting, which either recirculates the flow back to the mixed manifold through the pumps, through the fans, or through the overboard exhaust valves, of which there are 3. There is one here by the fans, another one here, and another one here. In our model, we're actually missing a small section of cabin here, and we need to add this. One option would be to select the group components and copy it, or if we were regularly making use of similar structures, we could have saved this previously to our catalogues and saved this as a subsystem, which we could then reuse again and again. So I can take my cabin section subsystem, drag it onto the model. I just need to move it to align it properly. And then I can just connect this into my network, selecting the circuit type, which in this case is humid air. So I can connect these components in. I also need to connect my heater. And finally I have a gauge here which is reading the volumetric flow out of the heater cooler component, which at this point I want to reach flow rate. The advantage to using a subsystem is any data you have previously entered will be stored in the component for later reuse. If we look at our model, we can see that all the nodes in the network are defined with a circuit type of humid air. And if we look at our cooling pack, we can see the fluid is defined as humid air, and we have specified a specific humidity coming in, and this will be used in tracking the humidity as we go through the system as the pressures and temperatures change.